We're going to want to start graphing some quadratic equations, and some of the quadratic equations we're going to start with are in a particular form. And the form that you see I have written here is in the form f of x equals a parentheses x minus h squared plus k. When it's in this particular form, we can view some things about the or view some characteristics about the graph just by looking at it. So we're going to go through and try to help you understand what some of the components mean. First of all, the first thing we want to look at is this a. What's that component or that coefficient right there? Is it positive or is it negative? If it's positive, I know the graph bowls up. If it's negative, I know the graph will bowl down. So in our example, we have a -2. So therefore, I know that the graph will bowl down. The second thing that we want to look at is where's the vertex of this graph. And we can tell where the vertex is at, or the vertex is at the point HK. Let's do it in, so the vertex is at that point HK. So if my graph that I'm looking at, or my function's in this particular form, I can just look at the value here in the H position and the value in the K position. So I have a value of 3 and 8. Or that's a coordinate pair where the vertex of the graph is at. Notice that I did not put a -3, because the form here is suggesting that I have the -h. So if it's already a negative right here, then that's the value 3 that I'm looking at. So I know if I go over to my graph, I have a parabola, it goes down, and the vertex of that graph is at the point 3 and 8. So I'm going to go over 3, 1, 2, 3, up 8, 1, 2, 3, 4, 5, 6, 7, 8. So I have a graph now that's just starting to take shape. A couple things I can look at next is let's find out where its zeros are at. We're basically saying if f of x equals 0, what are those x values, or where are its x intercepts? So in order to do that, I'll need to take the equation that I have here, set it equal to 0. So let's work it out. -2 x minus 3 squared plus 8 equals 0. So I'm going to subtract 8 from both sides. I'm going to divide both sides by a -2. I'm going to take the square root of both sides. X minus 3 equals plus or minus the square root of 4. Square root of 4 is a 2. So I'll adjust that here in a second. So I have x equals 3 plus or minus 2, or my two solutions. And so that's really the solutions. 3 plus a 2 is a 5, and the other solution, 3 minus the 2, is a 1. So I know I have two x-intercepts now, and this graph intercepts at the point 1, 2, 3, 4, and 5. So I can give a little bit more detail on this graph. One of the last things that I can determine on this graph is, well, where does it intercept the y-axis at? So in order to do that, let me clean my palette here a little bit. In order to do that, I want to find, basically, what is f of 0? What's the function evaluated at 0? So let's write down the function, -2 x minus 3 squared plus 8. F of 0 is saying, everywhere that I see an x, I insert a 0. So let's evaluate that out. Now I'm going to do it one step at a time. That's helpful for me. -2, that's a -3 in there, squared, plus an 8, -2, -3 squared is 9, plus an 8, so -18 plus an 8, and I get -10. So f of 0 is -10. And let's see if that makes sense on my graph. What it's saying is on the y-axis, or when x is 0, I have the coordinate point -10. Another way to say that is 0, 10. So I'm going to look for that point. The point's right here. So my graph also needs to go through that particular point, and based on the shape and everything that's happening, that looks realistic. So there is a rough guess, well it's not a guess, but there's a rough picture of what this particular quadratic looks like. And there's a couple of points that are very accurate on this. I know that the graph bows down. It doesn't hold water. I know the vertex is at the point 3 and 8. I know that it crosses the x-axis at the points 5 and 1. And I also know that it crosses the y-axis at the point 0 and -10. Now I can graph it. And those are usually the 5 things that we'll do as we're graphing quadratics that happen to be in this particular form.